So to this point, what we've been learning is that if I had a triangle, for example, with side lengths of 3 and 4, would you be able to find the third side? Sure, you could use Pythagorean theorem, right? And if I had another triangle over here with a right angle here and 20 degrees here, would you be able to find the third angle? Sure, because they all add up to 180, easy peasy. This unit, we've delved into the idea that we can actually take a right triangle if we know the angles, let's say 25, and we know a side length, but we're missing a side length, and we can use sine, cosine, or tangent to find for the missing side. So it's a blending of sides and angles that's kind of unique, but it's limited in that it only works for right triangles. Today, we're going to take that a little bit further. Now, if in fact I begin with a triangle that's not a right triangle, it seems offhand that I can't use sine, cosine, or tangent because I've got no angles, I've got no right angle to work with. However, I can make a right angle, can't I? I can drop an altitude from B. And when I do that, I create right triangles. So we're going to do a little derivation of a theorem called the law of sines. But before we do that, I have to talk about a naming convention. We began with this triangle ABC, and this a capital A, stands for what? Yes, the A stands for what? Yeah, it actually stands for a point. You remember we did that way back when. A capital single letter stands for a point. And yes, we can use that to name the angle. But what I'm going to do is I'm going to take angle A and I'm going to look all the way across to the opposite side. And I'm going to call it a lowercase a, which refers to a length. And then I'll take the B angle and go similarly all the way across to call this whole side B, and take the C angle to go all the way across, and this will be side C. And because I dropped this altitude thing here, often we'll call H for height. This is what I'm looking at. Now I want to use my sine, cosine, or tangent. I've got the right angle here, so I can do that. Say we're looking at this yellow triangle. If that's a right angle, of course, that's a right angle. And I don't have this length. I know that B is the whole length, but this little piece is absent. So what trig function could I use using like H and C, for example? Sine, cosine, or tangent? Good. So it's the opposite and the hypotenuse, so I could use so, which means I could say that the sine of angle A equals H over C. Everyone okay with that? Now I'm going to do the same thing over here. Here's another triangle. It's also a right triangle. And I want to use angle C. And again, I don't have this adjacent side, but I do have the opposite and the hypotenuse again. So I can say that sine of angle C is equal to what? H over A. Yeah.
So if it was sine, then it would be so, which would be opposite and hypotenuse.
Yep.
So, but you have adjacent. Oh,
but it's opposite the right angle, so it's the hypotenuse, right?
Oh no, for the other one, the left one, the left for that. Yeah. So it's hypotenuse. So it's so, which would be opposite versus hypotenuse. But isn't C adjacent to it?
Well, you could use the adjective adjacent to describe this, but the word hypotenuse also describes it because it's opposite the right angle.
Oh.
And the word adjacent we've been using to describe the leg, not the hypotenuse, that is adjacent. You're right that it's next to A, and that's the meaning of adjacent. But when we use the word adjacent, we're talking about the non-hypotenuse leg that's adjacent. Okay, now I've got these two equations, and what I notice is that they both have an H in them. And what I want to do is push them together so that those h's disappear. And the way I'm going to do that is I'm going to cross multiply. C times the sine of A is equal to H. And over here, I get A times the sine of C is equal to H. Since both of these expressions are equal to the same H, I can set these two things equal. C times the sine of A equals A times the sine of C. And you might not think to do what I'm about to do, but it's going to get us somewhere important. I'm going to divide by AC on both sides. On this side, the C cancels. On this side, the A cancels. And what I'm left with is the sine of A, angle A, over the opposite side is equal in ratio to the sine of C over the side opposite that. Now, prior to this, we knew that like in a 30, 60, 90 triangle, there was not a proportionality between sides and angles, right? 30, 60, 90. If I tell you that this side opposite 30 is 2, and that's a 30-degree angle, this angle is 60. So we might expect that it's going to be double, but we know it's not double. How big is this side if this side is 2? In a 30, 60, 90. This side's twice as much, isn't it? This is 2 times 2 is 4. Come on, you remember this. 30, 60, 90 triangles. 2 root 3. And so what we see is that if the side opposite 30 is 2, the side opposite 60, twice as big is not double. And the side opposite 90, which is 3 times as big, is not triple. So the sides are not proportional to the angles they face. But what we've just derived is that the sides are proportional to the angles they face when you take the sine of them. So this gives us our new theorem for today. It is on the first page of what's on your desk. It's the one that says law of sines. So in the theorem box here, please write the following. If you have a triangle marked in this way, with A, B, and C as the angles, and the sides being opposite, smaller letters, the sine of angle A over A, little a, is equal to the sine of angle B, so capital B, over little b, which is equal to the sine of angle C over little c. Now, eventually, when you get into pre-calculus, you're going to use law of sines and law of cosines in a more advanced way. Today, we're just going to kind of dip our toes into it, but I want to set you up for success for your future use. So whenever you do these types of problems, I recommend that we set up a little grid to keep track of our data. A equals, B equals, C equals, those are all capitals. And A equals, B equals, C equals, those are our lowercase. Now, in this particular case, nobody labeled this for us. So let's just put in some letters. Let's call this A, and this B, and this C. So how big is angle A? 71. How big is angle C? Could we find angle B if we needed it? Sure. 71 plus 35 is 106. 180 minus 106 is 74. So now we know all three angles. Do we know the side length marked as A? X, right? It's the side opposite A, so it's the one marked as X. Do we know anything about the side opposite B? Nope. Anything opposite C? 12. Now, having set this up, it gives us a vision of what we need to solve in the information we've got. The fact that angle C and side C are matched up and we have information for both is great. That's going to be part of our proportion. That's going to help us. And the fact that we've got little a as an unknown, and we do have the angle, tells us that we can use that as well. So really what we're going to use is part of this theorem. We're going to say that the sine of A over A equals the sine of C over C. Now let's plug in our values. We know that the sine of A means the sine of 71. And A is our unknown X. Sine of C is the sine of 35. And little c is 12. This is a proportion. And what's our best technique for solving a proportion?
Cross multiply.
Good, cross multiply. And what I'll get is X times the sine of 35 equals 12 times the sine of 71. Well, that sort of helped, but I don't have X all by itself. It's being multiplied by the sine of 35. So how do I isolate X so that I can solve for it? Divide both sides by the sine of 35. So what I'd be left with is X is equal to 12 times sine of 71 over the sine of 35. And as we've been talking about this unit, I do expect you to leave it, to get it all the way to this point. Show me the precise value in terms of sine, but then we're going to plug this into our calculator and solve it. So I'm going to go 12. Oh, what do I do to check my calculator first?
So you do sin of 35.
And I hope it's going to become what?
5.
0.5, right? Because the sine of 30 is 1/2. All right, so then I'm going to do this. I'm going to say clear 12 times the sine of 71. Do you see where it's doing right now, my calculator? 12 times the sine of 71. And to get the 71 in there, it opened up a parentheses. If I don't close the parentheses right now, I'm going to be dividing the angle measure by sine of 35. So close those parentheses, then divide by sine of 35. That gives me that X is about 19.78. I would like, as normal, to please round to the nearest hundredths for this assignment. How do you feel about that? 5, that seems easy. 3, I wouldn't call it easy, but it's doable. 1, I wouldn't call it easy, I wouldn't call it doable. Okay, good. Prove it. Do number 2 now, please. How'd we do? Check up on the screen, please. 5, I got 14.782. I rule. 3, I got close to that. I think I'd get it next time. 1, I'm still working on which triangle we're working with here. Okay. Any questions? Okay. Step 2. Instead of finding side lengths, we can sometimes use the law of sines to find missing angles. But like we discovered in sine, cosine, and tangent, the geometry is the same. It's just the algebra. So how would I set this one up using the geometry? Number 9. Okay, so ABC. We'll label A equals B equals C equals. And for those that like structure, this is a great way to begin. Soon, after doing just a couple of these, I expect you won't need this chart. Because do we know which ones match up? These two, don't they? So we could say that the sine of what? Sine of 77 over 14 equals. Ooh, careful. X is the angle, 9 is the side length. Sine of X over 9. Okay, so that's the geometry, and it's the same. It sets up the equation. It's now a proportion, so we solve that by doing what? Cross multiplying. So I'm going to get 14 times sine of X equals 9 times sine of 77. And I'm always trying to isolate X. It's got this 14 times it that I don't like. So how do I get rid of that? Divide by 14. So now I've got the sine of X equals 9 times the sine of 77 over 14. But I don't want the sine of x, I want just x. Yeah, how do I get rid of sine? Inverse sine. Arc sine, it's sometimes called. At which point, I'm just going to use my calculator for this, but be careful of the parentheses. Second sine, 9 times sine 77. I have to close that parentheses before I divide by 14.
Wait, so how do you do the minus the sign?
How do you do it in the calculator?
Yes.
On each of the buttons that says sine, cosine, and tangent, just above it in yellow,
Right.
it says sine with a little -1 exponent, cosine with a little -1 exponent.
I need it second.
Exactly, hit second to access those. If you got domain error, that means you tried to create something that is outside the realm of possibilities. Let me see if this would do it. No, that would do it. Sine is always between -1 and 1. So if you're trying to take the inverse sine of something bigger than 1, that wouldn't work. So we want to take the inverse sine of 9 times sine of 77. Did you maybe forget the sine?
I did 9 times sine.
9 times sine of what?
I did 9 first and then times second sine.
Yeah, we're taking the inverse sine of all of it. So we're going to just enter in our calculator this inverse sine of 9 times sine of 77. Make sure to close that parentheses and then divide by 14. And we get an answer of 38.78. And that's an angle measure now, measure of angle x. It's a little harder. Would you please do number 10 yourselves now? Yeah.
I got like a really close answer, but not, I don't think it's the right one.
Okay,
Okay.
just a second. Please give me at least your focus to make sure we finish this one. So the sine of 126 over 31 equals the sine of x over 15. 1 times sine of x equals 15 times sine of 126. Sine of x equals 15 times sine of 126 over 31, which means x equals the inverse sine of that whole mess.
No.
So, come on, nobody? So, Katoa, thank you. Please flip to your second page. It's called Law of Cosines. And I want you to look at problem number 1 and see if you can solve that using the law of sines. When I say solve the triangle, what I mean is find the missing parts. Can you do that for number 1 on the law of cosines page? How we doing? You can't? So I don't have the A angle. I do have the B angle. I don't have the C angle. I have A's length and I have C's length. And B is my X. Can I do this with the law of sines? Do I have a ratio of a side and an angle that will give me the one ratio that's solid? Like, could I do sine of A over 12? No, I don't have A. I could do sine of B over X, but do I have sine of C over 7? I don't have enough. I'm going to have two variables left in here. So the law of sines will not solve a problem like this. Fortunately, there's another theorem called the law of cosines. It's more complicated, significantly more. No, it's not cosine of A over A. I'll give you one. A squared equals B squared plus C squared minus 2BC times the cosine of angle A. Now, here's the best part. Because we don't have a right angle and a hypotenuse or anything to orient us, the side lengths could be in any place. So this isn't the only version of the formula. There's a second version where B goes here. Any guesses what comes after?
Okay, so B equals A squared. Oh, well, okay.
Right? Minus 2AC times the cosine of B. Good. Can we get the third one? Don't say it out loud. Try to write it down. If C is being used up for the front part here, what are the other two that go here? We've already got C squared, so A squared plus B squared. And then which two letters get multiplied by 2 here? A and B. And which angle gets cosigned? C. Now, I will tell you right now, you are not responsible for memorizing the law of cosines. Woohoo, cheers, yeah, okay. But let's apply it. So what I've got is B as an X, and I've got angle B. Which one uses angle B? The middle one. So let's write that out. B squared equals A squared plus C squared minus 2AC times cosine of B. And let's fill in the values. This time, what do we have instead of a B? X. What about side A length? And C squared minus 2 times 12 times 7 times the cosine of what's angle B? 65. Let's clean it up a little bit. X squared equals 144 plus 49 minus 264. 2 times 12 times 7. 168, not even close. Okay, now, do I need much to do here? Do I have any solving to do, or am I just looking for what this whole mess equals? So I can actually just use the calculator and plug it in. I can go 12 squared plus 7 squared minus 2 times 12 times 7 times cosine 65. And it gives me the big number. Now, I want to solve for x. So what am I going to do to both sides? I'm going to square root. Now, in my calculator, when I do this, I've got that value right there. I want to square root that. But I don't want to write it down and then copy it back in. A, because that's a lot of work. B, because I'll probably end up cutting off some decimals. I'll lose some precision. So there's a feature in our calculator we can do. I'm going to press second squared, which gives me the square root. What do I want to take the square root of? That last thing I had. So I can press second, and then the little minus sign at the bottom here where it says answer above it. And what that does is it takes the square root of my prior answer and gives me the result, 11.05. All right, would you please do number 2? How'd we do? 5. It's like I'm ambidextrous. I can do law of sines and law of cosines. 3. This one's a little bit more confusing for me. 1. I don't believe in laws. Okay. Last piece of instruction for today. Flip this document over. Backside of law of cosines. Flip that over. Backside of law of cosines. And let's label it again. A, B, C. Identify the values you've got. Which version should be used for the law of cosines for this one? C squared? I like that. Why?
Because you have x.
You're trying to use angle C, right? So we're going to want to use angle C, which means we start with a C squared. That means it equals A squared plus B squared minus 2AB cosine of C. Let's plug them in. X squared equals 12 squared plus 11 squared minus 2 times 12 times 11.
Sorry.
Yes,
Wouldn't x squared, would that be 7?
thank you. You're right. I was thinking about a different problem. This one is 7 squared to start. Thank you.
Thanks.
Which makes sense because we should only have one variable in this, right? That's the way we'll solve it. And let's simplify a little bit. 49 equals 144 plus 121 minus 2 times 12 times 11, 264. Right? What would be our next simplification? And feel free to write out lots of lines. So go small. What's the next small thing to do? Say again? Okay. Let's combine these two. So 49 equals 265 minus 264 times cosine of x. Right here is where everybody makes mistakes. What's the next step? That's the mistake. We can't subtract 264 cosine of x from 265. It'd be like subtracting 264x from 265. They're different. So we got to cleave this part off first. It's being added, so let's minus it or subtract it. Minus 265 on both sides. It gets 216. So negative 216 equals negative 264 cosine of x. And we're trying to solve for x, which means we have to undo all the things being done to x. That includes multiplying and cosining. Let's get rid of the multiplied by 264 first. How do we do that? Do we add or divide?
Oh.
We divide because it's being multiplied. So we need to divide by 264. Again, this is where people make mistakes. This couple of steps here is the problem. We're now at this fraction, whatever 216 over 264 is, and that's equal to the cosine of x. Yeah, we're going to undo the cosine part. And if we do that to both sides, inverse cosine or arc cosine, what we're left with is x equals the inverse cosine of 216 over 264. Try that in your calculator, see what you get.
Why is it not negative?
It was negative on top and negative on the bottom. So negative divided by negative is a positive. Yeah. But you can leave it negative, negative. That's fine. For rounding to the nearest hundredths, that would be 35.10. Right? A little harder, isn't it? No? Prove it. Do number 6 now, please. All right. You guys need more time?
I want to know the answer.
All right. So did we get to this stage?
Yes.
Did we get to that stage?
Yes.
In other words, we recognize that this 832 needs to be subtracted. We don't do a little simplification here because this is being tied to the cosine of x by multiplication. So we subtract 832 from both sides. We get 393. And what we're setting that equal to is a negative 768 cosine of x. We need just x. So first we'll cleave off the negative 78 by dividing by that. And that leaves us with our fraction. Now it is a negative number, is equal to the cosine of x. In order to solve for x, what do we do to both sides?
You do negative cosine.
Inverse cosine or arc cosine. And again, we can use that calculator trick for this one if you want. Negative 393 divided by 768 gives me that decimal value. And then I can say second cosine, oops, it took that value from me. I want to pull it back. So I'm going to go second and down here to the answer button. And now it pulls back that specific decimal without any rounding issues. Enter. And I get 120.78. Does that make sense to you? Is it a reasonable number? What components make it reasonable? Angles, yeah, go ahead. You put exactly this into your calculator and you're getting syntax error?
Yeah.
Okay. Let me come check with you in just a second. Well, first of all, this is reasonable. The reason I suggest it is for two reasons. One, we know that triangles and triangle angles add up to how much? The three angles in a triangle add up to 180. So having it below 180 is important, right? It's not negative, it's between 0 and 180. Secondly, it's opposite the biggest side, which makes this classify as what kind of triangle? Obtuse. Therefore, an angle opposite the biggest one must be bigger than 90. So it's in the right ballpark. That's about all we can do for now. Okay, for today, the easier ones, the law of sines page, side 1 and side 2, is your responsibility. You should be familiar with law of sines. You should memorize that formula. You will be tested on that. This stuff, the law of cosines, is informational at this point. You are not going to be held accountable for this on the test. You don't have to memorize these formulas. You will need law of cosines in higher levels of math, but not in like immediately lower levels like advanced algebra. So if you're somebody who's going into like honors advanced algebra next year, you should do law of cosines page 2. This is of interest to you. If you just enjoy the process of practicing the arithmetic that this forces you to do, and you know that's what you need for the algebra skills survey, then you should do law of cosine sheet. But this is optional. If you don't do any more than this, just the ones we did here, you'll still get full credit. You will not, just the satisfaction of a job well done and more knowledge in your head. Okay, you've got the rest of the period. Please use it wisely.